Dave Noor from FAA joining us. And Dave actually has worked at FAA or in aviation field for more than 40 years. And in aviation area more than 40 years, but in FAA more than 30 years. That is a long time. And currently he leads the system analysis and modeling for the FAA's Next Gen organization. Next Gen stands for Next Generation Air Transportation System. And that plan actually started back in 2005. It aimed on modernizing the National Airspace System. So his team is responsible for reaching an agreement with airlines on the value of new technology and procedure implementations. And they've actually held numerous positions with FAA, including serving as FAA's representative in Europe. And I think you stayed in Germany as well as France, right? And then he holds a degree in mathematics and a master's degree in industrial engineering and operations research from Virginia Tech. And I have known Dave for how many years? 20 years.
Since you were a graduate student, before you had your PhD.
Yeah, since I was a graduate PhD student at UC Berkeley, that was back to 2005 to 2003. So yes, about 20 years. After I joined the USF, I kept working with Dave through the Nextdoor. So Nextdoor is a university consortium to support FAA, especially on how to apply operations research in air traffic management. So I'm very grateful that Dave's office, keeps on supporting our aviation research at USF. And almost every year, I think Dave, visit us and we report the progresses of our projects and also gain a lot of valuable comments, insights, and recommendations from him. So today is the yearly visit of Dave to our campus again. So we're glad to have him, and we take this opportunity to invite him to give us a presentation in our seminar. So join me to give a big applause to Dave, and thank you for being here.
Thank you, Professor Zhang. So my team in the FAA, we're part of systems engineering. And in systems engineering, we look forward and we're trying to use data to try to build arguments for where we need to invest and where the air transportation system can be improved. All right. I mean, there's a lot of companies that come in, there's a lot of, and there's a lot of arguments, but we try to do things data driven, and my team has that data. And I think Professor Zhang will tell you I don't know of another industry where there's more data than aviation. I mean, back to the 90s, we have every flight, 50,000 flights a day, every 12 seconds of their trajectory until they get close in, where we have it every 5 seconds, 4.8. And then around the airport, we have it every second. We know the weather conditions that were going on. We have the type of aircraft. We know the configuration of the airspace. We know the controllers that we're on. It's a massive amount of information. In fact, I don't have any of it here, but a lot of what we're trying to do now is how can we use machine learning, AI to do, because there's so much data. So what I'm going to show you here is going to be a little bit on what some of the problems in aviation are, and how things changed prior to COVID versus after COVID. This is a volatile time right now. Demand, people are moving to different places. Florida is a hot spot. You'll see that. People want to go to Florida. I'm here. I mean, I don't really want to be up north. I mean, it's great down here this time of year. People seem to want to go to a lot more to Vegas. Texas is growing, but this really changes where the issues are in air traffic. So I want to keep you all entertained, and I want to keep you, I'm not going to have any fancy formulas. We leave all those to Dr. Zhang. I'm just going to show a lot of graphs that I think you all might have some insights into how you could build things. But 4 topics today. One is, how has demand changed across the US for air traffic? And I know a lot of you are international students, so I even have some international info. You know, and how has it impacted the NAS? We kind of set things up for a certain amount of traffic to fly over top. When you think of air traffic control, you guys probably think of control towers and airports. But 13,000 of our 17,000 controllers are in these big centers that are broken up into 40 sectors, and they're controlling traffic mostly from 18,000 feet and above. They're separating it. And these folks are, it takes a talent to be able to be an air traffic. I'm not an air traffic, but it takes a talent. We implemented some changes at Denver, and we're going to take a look at what happened there. And then I'm going to show you a little bit about what makes airport capacities differ. So I just want everybody to know where things are. Everybody, does everybody here kind of know where the major airports are? But ORD, all right, DFW, Phoenix, LA, San Francisco. We're going to talk today about the New York area. This is down where you are here, and this is going to be exciting, what happens down here. Atlanta. All right. Not a great slide for you to read, but basically traffic has gone up. VNY is Van Nuys Airport in California. Huge growth in traffic in Van Nuys. This was kind of a surprise to me, but you know, airports like St. Louis are down, Salt Lake's down, San Francisco's down, Philadelphia's down. Who's up? PBI is Palm Beach. Florida is up. Miami's up. MCO. What does MCO stand for? Orlando. Give that kid a cookie afterward. Orlando. LGB. I honestly don't know. That's not like LGBT or no. I don't know what LGB is. LAS, Las Vegas. DAL is Love Field and yep, AUS. Oh, it's Long Beach. What's AUS? Anybody a cowboy? Austin, Texas. And Austin, Texas is up, and BNA. I know BNA. I think that is a Florida airport. But anyway. Oh, Nashville. Everybody wants to go. So overall, you can see there's seasonality with demand. This overall curve is showing demand. This is what happened after COVID. And you can see we're coming back overall. We're not quite there yet, but demand overall is coming back. But look at delays. Delays pre-COVID, delays after. You look at that and you'd think airlines are happy, everybody's delays are down. Well, we're going to keep looking at what ends up happening here. These are causes of delays. What would you imagine the biggest cause of delay, given that you probably can't read that? What do you think the biggest cause of delay is in the airspace? Weather. This one is called volume. Other can be things like airport construction. It can be controller staffing. But volume is when there are more planes than we can handle, and we input or infuse delay to the system. So let's keep looking. There's Tampa. Tampa delays are up. All right. Let's keep going. Miami delays are up. But what do you notice about Tampa delays? The traffic is kind of getting above where it was before. So if you're in transportation, more demand than capacity, you get problems. More demand than capacity, airlines get pissed off at the no, they're not happy with they want us to keep keeping ahead of that. I don't think pissed off is a word you can't say on TV or anything. But look at Miami's traffic, way up, way up. All right. EWR. Anybody know what EWR is? Newark. Newark. It's a big hub for United. Traffic down a little, delays down a lot. Anybody, you know, it's an exponential function when you get to where demand starts to hit capacity. Let's keep going. LaGuardia, New York. Anybody ever been to New York? Yeah. All right. I know you've been to New York. San Francisco. Delays are way down. Delays are way down and traffic's down. All right. Whoa, what happened here? Las Vegas, traffic up, delays up. Atlanta down. I'm just having some fun showing you some things. So this is what's happening at, whoa, that is the Las Vegas graph with a, I don't think Professor Zhang was supposed to look these over for any problems. I think she might have missed that one. So let's just go to international. I told you I'd tell you something about international. The blue is overflights are things like from Canada down to South America, or from Canada to Africa, or from you know, things that go over to the United States but don't land. We actually charge money for that. But you could see Mexico, Caribbean, maybe a little bit up. Canada down from Canada. Europe, close. South America, a little bit up in the latest. Whoa. Flights to Africa, not as many on a scale here, but are up. And Australia, a little down. So you may find yourself in there. All right. Remember I said I said 13,000 of the controllers. These are our en route centers, of which every one of these things is broken up between 32 and 46 sectors. So, and the sectors would break these up, that a controller handles the traffic as somebody's coming at high altitudes from one to another. These are our centers. This is called Jacksonville. This is Miami. ZDC, ZNY. All right. Let's watch what happens to our centers. So this is the traffic across all the centers, and delays are, well, you got to compare 2019 to 2023. It's kind of not determinable yet where we are, but when we get down underneath, you're going to see some mess. ZDC is down. All right. ZOA, that is Oakland, down. ZNY, New York, down. I should have had the picture up there. Whoa, Jacksonville. Whoa, this is a problem. It's a bigger problem. Why is Jacksonville a problem? What happened at Jacksonville? And why are the airlines, they're not so happy? Well, travel going down there is up 6 to 10%. We have way more launches coming out of Florida, which block off traffic. That's another. And During COVID, I think this is an interesting thing. During COVID, we couldn't bring people in to train controllers. We had a 2-year period where we did not bring on new trained controllers. So when you have people that retire and a new pipeline and you've got a controller workforce of almost 20,000 people, who's that guy? No, we fell behind. So that's part of the control. You know, that's the worst thing to hear your own voice. Just throw that thing down. Okay. All right. This thing's mocking me. You just turn the phone off. All right. Thank you. So the FAA created a whole bunch of new routes. Now, you won't really be able to see it, but this is the old route structure. This is the new route structure. Not a big difference, but the new route structure is all based on GPS coordinates. It has nothing to do with underlying ground infrastructure. For years, the infrastructure for routes across the country, there's these VORs that are all over the country that shoot out directional beacons, and an FMS and an aircraft can take that to fly its routes. So we replaced all that with more efficient routes. So you can imagine this article comes out. This article comes out in May of 2023. Oh, thank you. Thank you. In May of 2023, and the airlines are saying, but it's still terrible going to Jacksonville. You know, you're overstating, because it's a pretty positive. So if you go down here, look, it was a lot of work to put in this new route structure. And truthfully, it's more about not having the ground infrastructure to maintain. That's more of the benefit. But somebody in our comm office took this and made it sound way better than it was, except for this. This came out from people I work with. It says the direct routes will shave off 6,000 minutes of delay. Do you know how many? You get 1,200 aircraft are going back and forth a day through Florida. Does 6,000, you know, how much is that? That's 20 minutes a day total over 12,000. That's not a big savings. But I made this big for you to see it in the article. It was just, so we actually still stand by this. But how do you get to that savings? That savings is because we've increased throughput, and we've actually shaved off and created some straighter routes. But we haven't changed the capacity of Jacksonville Center. So if you if you make routes a little straighter and you add some routes, but the capacity that a controller can handle in Jacksonville Center didn't change, problem. And so delays have gone way up. And I, as part of my team, we'll keep going here, you'll see. So here's Jacksonville Center. So, you know, everything coming to Florida goes through Jacksonville Center. It goes into the Gulf and it goes out into the Atlantic. All right. All right. Now, I know I've told you some of the same things, but look how much traffic has gone up into the Florida airports also. So it's something for you to think about if you're in transportation and you have a customer and you do something good, but because of their demand, things get worse. It's kind of like you put a new road in, you put a new lane in, more people drive on it, and you really need to normalize for how things do. So look at the launches go up. When the launches happen, we have to block off airspace coming down through there. We're trying to get to where we can block it off shorter and shorter, but launches, funny thing, true story, I think it's true. But we were told, we were trying to complain to Elon Musk about the impact of these launches. Now, the other side of the US is we do want to lead in technology, and we want space launch to grow, of course. But he said airlines are complaining. Elon Musk said, send me the bill. So we're not sure how we're going to do that, but that's an interesting comment. Have the airlines send me the bill. Because what we're making off these launches versus, okay, just a picture of, you can see things north and southbound going, this is like a day of traffic, folks. It's a lot of stuff. So the way we do it is we put out these lines, and then we probe in history for 1, 2, 3, 4 hours in advance. We have flight demand that airlines give us, and we probe what the demand is. And then we allow airlines to trade within themselves, and we constrain how much comes across that line so that we can control the workload. That's what the FAA does to, I guess it's like metering a road. All right. Well, so I'm about to start in fact, the kickoff will be the 31st, this discussion about what's happened with these new routes. The crazy thing is, if you go to New York and look the other way, things are way better. Things are way better going in the other direction to New York. So airlines don't really want to hear that. New York was the big problem. So it's going to be an interesting. So, like I said, I will be the joint co-chair. This is hot. It's hot stuff. I think it's kind of fun because it kind of goes back to the political challenges of doing something. But we will evaluate this jointly. Clearly, it's up. Delays are a function. And the FAA, we do have plans to increase capacity, but it's on our timeline. There are other issues we're working on, and it will be we take input from the airlines, but we ultimately know where our staffing is, where we're doing other things, and we'll ultimately try to make the best decision. It won't always make our customer happy. Make sense? All right, so, all right, it gets a little, now we're gonna talk Denver. And Denver, we've done something good too. We've added a whole system that allows us from 600 miles away from Denver to start keeping aircraft on the ground if there's going to be too much demand at the Denver airport, or slow them down, because if you let too many airplanes go in, you could have holding, or you could have long routes in the TRACON. So that's not what we want, but we also want to keep throughput up. So that's the story I'm going to tell you here. Here you can see for Denver that demand is up a little bit. This is daily. This is like daily demand. Denver got rid of a morning peak. This is an airline thing. They got rid of a evening peak, but they peaked up. But this is all part of our equation. One interesting thing is we are keeping Denver, you can land on 3 runways. We are keeping 3 runways open more often. We also are employing a new technology. It's not so new anymore, but on the aircraft, Dr. Zhang and I were talking about separating. If you have the right equipment on your aircraft, you can be given a R&P arrival approach here, and with that equipment, you can fly a perfect, you're going to stay within 0.3 miles of that arc, and these are real plots in the blue, no matter what, you're going to stay on that arc. And by staying on that arc, we can project because flights are coming in here also, and flights are coming in here. So we can project and better control where you are. So you get better service by being on this R&P. We're pushing for airlines to equip and train their pilots for that technology to fly very precise. I know you're probably looking at yourselves like, I can do that in video games all day long. Why is this such a big deal? Well, the winds that you project, winds can be dynamic in precise moments and throw you off. And the aircraft has to be able to keep within that. It's not as easy as you think is maybe the better. And you can't have any failure in your FMS. So to do this, you need to have a dual FMS, flight management system, in the airplane. So arrivals at Denver. This is a little bit of concern to us. If you look at, I want to make sure I get this right. If you look at max arrivals, we were doing better pre. So that's a concern. It's a concern because we're trying to improve fuel efficiency by keeping them back on the ground, but we don't want to see that we want to still deliver the same amount. So, all right. I think I already told you about this, about how we you know, you've got an en route portion. I talked about that. You know, just a thing, when we meet with these airlines and we discuss whether things have gotten worse or better, one thing we have to adjust for is where is the traffic coming from? Because pre and post COVID, the traffic coming into an airport is coming from different places. And you're going to be treated differently depending on where you're coming in. It's straight in here from the south. You're going down and around. So we've got to normalize for all that. That's things we do. One thing we do for our measures is we try to say that a 15th percentile flight would be our perfect goal. One day, if we could build a system to bring you to this point at an exact time, we want to keep the throughput up at the runway, but we want to minimize the fuel burn and the uncertainty out here. This is what happens all the time. We just adjust by further here. So we're looking for more consistency. So what we calculate is distance above this 15th percentile, and that's something we say we could improve by either moving it to a different place, moving that, and that's why we call it, we used to call it necessary delay. There was a time when we first developed this, we'd call this extra delay. Air traffic controllers, I remember doing a briefing and he's like, are you crazy? Extra delay? I mean, I got to move him out here to sequence him with the other aircraft. This isn't extra delay, this is safety. So it's an opportunity to be improved on, but they're very sensitive about how you talk about it. Any controllers are listening. I feel your pain. We have basically, I skipped a lot of steps here, but we've shown a lot of different methods that the sequencing delay, including looking at these in multiple variable, but the sequencing delay appears to be down for the same demand. All right. This is 2019 sequencing delay. Now we're now going to talk about how much sequencing delay versus the pressure. So the bottom here is, this is going to be probably about as complicated a chart as it gets, so stick with it. You can get it. No, this is how many aircraft are in the TRACON. How many aircraft are with you inside of 40 miles? So, and this is how often there are this many aircraft. So most of the time, you're inside with about with about 11 aircraft, or in there. But the sequencing delay, that delay above a 15th percentile, goes up every time you have more aircraft in the TRACON. This is completely intuitive, right? If you jam more in there, you're going to have to vector more. The controller's got more people he's got to try to land. Okay. All right. This is that was 2019. This is 2022. All right. Same type thing. Now we put them together, and you see that at the same demand in the TRACON, excuse me, we are having less delay at the same demand. Now, why might that be? Now, you see it goes kind of crazy out here. Now, what we do as professional analysts, we say sample size is low, don't look at that. That's what Dr. Zhang has taught us. So I think I already said all this. We're trying to meter. So one of the things we're also looking at is the introduction. I told you that more people are getting R&Ps, which are those short. If you're equipped, they can, and you're on a precise path, they can squeeze you in. So now we're getting a lot of stuff going on here, but this is the proportion of R&Ps in 2019 versus 2023. We've got a lot more equipped aircraft, and we think that is contributing to this difference. It gets crazy when you get, when you get this many aircraft in a TRACON, it can be there's a thunderstorm in the TRACON. It can be a runway event. Somebody had to go around. It can be weird stuff that that we do study. All right, let's keep going here. Clearly, sequencing delay when you're flying R&Ps is better than when you're not. That is intuitive. So throughput has increased, pressure has remained similar, sequencing delay is in. We're doing some work right now where we're very concerned that we are not using the available capacity as well as we were. How would that be? It would be like if a road metering light was keeping you so long that it didn't keep enough demand on the road. It doesn't really happen that way, but that's something we're looking at. All right, arrival capacity versus throughput. Inter-arrival time, not complicated, right? Two planes land, and what's the time between them that we're actually measuring? We have a safety threshold, which would say 2.5 miles, but they always buffer more than that. And we're looking at, you know, why do different airports, why are we behaving differently? And we're trying to kind of set the stage for, if you can get inter-arrival spacing to be perfect, to be very close, you increase the throughput in the capacity, right? I mean, that's a good thing. Now, this is simplified because in reality, if this was a 380 and this was a 737, that becomes 6 miles instead of 2.5. So the 2.5, so it does depend, but when it's equal aircraft, it can get down to 2.5. How am I doing on time? Okay, all right. All right, so we have developed, this has been around since 1972 for determining aircraft capacity, airport capacity or runway capacity. We look at the sampled inter-arrival spacing. Now, what's the challenge of developing the performance of an airport? The challenge is a lot of times the demand's not there. You know, you can only measure this when demand is high, because if the demand's not high, then the inter-arrival times are going to be driven by the demand and not by the, so, but by looking at the mode and our human factors folks and our controllers have kind of bought into this, that in a high pressure situation, they're going to err to the left about the same as they would err to the right. So we kind of grab this as being the real performance distribution from a large sample of inter-arrival spacing. The right tail, this tail here, again, is driven by times when there's not demand. Imprecision in hitting the desired target. Now, another thing we look at is we allow for about 5% of the inter-arrival spacing to be less than the safety goal, because that's just been determined as okay. Because you're what right now I don't know if I have a slide that has buffers on here as opposed. Okay. Now let's have some fun here. Atlanta is the best operating airport in terms of inter-arrival spacing in the NAS. And this graphic is for equal aircraft types. So anybody have a thought on why Atlanta? Well, I mean, the reason this is interesting is in a lab environment, we had Atlanta controllers working with Denver controllers, and we have a new system which we ended up not deploying that would help controllers tighten things up. And the Atlanta controllers thought there was no reason Denver couldn't tighten up as much as them. But they were wrong. What do we know is different about Atlanta? It's 6,000 feet above. The aircraft actually land going about 13% faster. And when they're going faster, you might think a little faster could help throughput, but when they're going faster, they can't get to the turnoff, and they're on the runway 13 seconds longer. So they don't get off the run. And that's the one thing you can never do. You can never land an aircraft until the other aircraft is off the surface. So this was it's kind of obvious. But then the other thing, I work with a United pilot who made a really interesting comment. He said, when I flew into Denver, we also would go easy on the brakes. We wouldn't even try to get because if we went hard on the brakes would, and when you go into Denver, you're going in, people are changing planes, and then they're trying to get back out within a half an hour. You've all flown. An aircraft comes in, people board off, people board on. But he said the brakes couldn't cool within that half an hour, and they weren't cleared to leave the gate. So in other words, more reason why Denver. The other thing, Denver has more go-arounds, which means more missed approaches than anywhere. They have 50 a month, where the next one might have 6 a month. And the reason is because they're so high up, and as you're coming down, wind directions, the change in wind directions in Atlanta as you're moving down altitude is more than anywhere, which makes it difficult for a controller to space them because, he's looking at them, but if you're in a wind, they're not, they don't have those projections. And so it can mess up. So they like to add a little buffer. Bottom line is Denver can get better, but Denver can't. But this one perplexed us. LAX perplexed us because LAX is sea level. But we said, it is on the West Coast. But why does LAX? We'll talk a little bit about this. But MCO is where again? Orlando. Did you know, well, let me go to the next slide. Because Orlando, these all have parallel runways. Okay, all right, what does this say here? Final approach speed, runway occupancy time, okay. Straight inverse downwind. 85% of the traffic going into LA is coming from the east, coming from the East Coast, and they all line up from a long way away. That plays a role there. We really think, I'll tell the story, but we really think that for Orlando, the flip normal, looking at their real performance, is not a fair characterization, and we'll go through that. All right. Okay, so this is pressure. Yeah, look at this. Atlanta averages in a peak 24 aircraft in the TRACON, MCO in a peak. So despite all these people coming to Disney, what else do we have besides Disney that they would go to Orlando? USF, one of the top schools in Florida. UCF, not one of the top schools in Florida. Yeah, all that stuff. They have way more capacity still to go. They are not doing near the operations of an Atlanta or other busy. And the reason for that is they're a destination, they're not a hub. The busy aircraft have maybe 40% of their traffic is destination, but it's the hub that makes you a busy airport. And Miami is more of a hub to go to South America, but right now, MCO is not a hub. And by the way, they have more room on the airport to do UAM than your TPA. So you might want to try to get money from them.
If their arrival time is very higher than other airports, is that caused by they do not
Yes, that's what I'm saying. No, there's not. Well, that's a great question. They don't, no, it's not because they're being kept away either. They just don't have the traffic. Yeah, I should have. You're right. It's not that we're keeping them back. It's that they just don't have it. They have more excess capacity, so that measure doesn't give us the, all right. So these are just by pressure, high pressure only. Still things are different. For this one, we went and we can't do it versus the others because they don't ever have it. So you're right. I mean, that was that was when we had the finding, but we tried to do it by the same, but they're in such different categories that it as a percentile, yeah. But even taking, if you took the 90th percentile at MCO and the 66th percentile at Atlanta, you still don't. So we played with some of that, and all right. So look at this. Atlanta on the left, percent of flights arriving in high pressure. Atlanta is still way down. Denver, we're a little worried about Denver. The pressure is down because we are controlling it. So that is a concern on Denver. LAX, its pressure is down and its IATs are different. Yeah, here we see MCO was maybe a little better. 2023, some airports are, this is a comparison, and these two colors look very similar to me. Yeah, but you can see LAX is still at higher, but I think he's going to have a chart in here, or we're going to have a chart. I took him out, but basically, I've shown you some pictures, but basically what's happening at LA is because 80% of the traffic is coming straight in. So picture the United States. LA is on the West Coast. So they line traffic up 200 miles away. They're lining them up for 2 runways into LAX. Now, a lot of us thought before the research I didn't show you, but a lot of us thought that if you have all that time, you should be able to get the spacing perfect. But in reality, when we look at everywhere else, the best spacing is when you have a mix of a guy coming around and in versus a guy coming straight in. And the best spacing, and this is counter to what we want to show, and it really means we need more FAA tools. But I mentioned we were flying those R&Ps. When you're flying that R&P and you're behind a straight in, we have a higher IAT than if we were flying visuals behind that when the traffic's low, because a visual can take a shortcut. So a lot of our work, did you buy lunch for us? the visuals, the R&Ps that are really good for predictability don't give the controller the flexibility to give you a shortcut. And having a shortcut helps. I think if I think, oh, here. So if we took this picture, well, Atlanta doesn't have R&Ps, but let's say the R&P was here, out here. They can't build it in so close, but if it was a little, then the visual shortcuts can actually give you another variable to reduce that inner arrival. The bottom line is we are trying to give controllers tools and aircraft tools to improve by seconds that spacing, because one more arrival an hour means something. I mean, it means a lot of delay. It means an extra connection. One more arrival an hour per runway means something. And then you have Dr. Zhang, who is doing studies about how we're going to land these UAMs on the aircraft, on the airport. Who knows what trouble that's going to cause. No, we are all supporting that, but that is going to be challenging to land. These UAM companies want to land inside the airport. They don't want to go a mile away where you come through the terminal to check in. They want to be inside. That's infrastructure, and if they're treated as helicopters and they're in visual conditions, can work up to a certain number of operations. It'll be challenging in IFR conditions. That's a whole other topic, but the reason that our team is so interested is we gave Dr. Zhang a project to study the tower controller's workload if UAMs coming onto the airport were to really grow. And our purpose for that was, could that have an impact on traditional aircraft, which that's the research question that you all are looking at. So what we're saying is, definitely with somebody like MCO, our flip normal doesn't work. That's pretty obvious to you, but it wasn't so obvious to the community. The funny thing was, before, just to let you know how data has changed. 10, 15 years ago, we didn't have 1 second data on what's happening at the airport, or really high update data, what's happening, what runway, I mean, where we could tell exactly which runway they're going to, what the separation. And the way that the original capacity studies were done, so, somebody went to Atlanta, which was our good place, and it was stopwatch and industrial engineers just timing it. This really happened. I mean, people really did that. But now, electronically we can pull in, and so now we can just do much better evaluations of what we're doing. That's all I got. I'm going to sit on this chair. Any questions about anything? The Washington Redskins? No, what are they? So who here has an interest in aviation? A couple of you have to, because you work with Professor Zhang. So. And everybody's flown. Mm-hmm. Yeah, that's a great, there are, I kept this simple, but in VMC, in visual conditions, there is the only limitation to when you can land between airport is that the other aircraft is off. So it's only runway occupancy time. In instrument, when the visibility is lower and on approach, you're not going to be able to see the other guy. It goes to 2.5 and in some airports 3 miles. And it actually is more complicated than that in that if they're parallel independent runways, then you're not worried about the two flows. But if the runways are dependent on each other, then there's even a further degradation on the capacity in lower visibility. Winds, winds also change the capacity, and controllers will call that. That's not, they will actually make changes. So there are tables for every airport that there are more factors, but people calculate that through, we just have much more data to look at that. But what I was showing you here is if you're trying to do the capacity from what you actually see, you have to know that you've got enough data and in an MCO. But there are all types of projects where people are trying to optimize. We had a project in the FAA called TSAS that as you came into the TRACON 40 miles away, you went into a bubble for best use. And that bubble moved and the controller had to move the plane to stay inside that bubble. All right. And it would tell you which runway to go and what sequence. So it was an automation tool trying to optimize better than the control or better than the average controller. What happens with those is they tend to work in fairly stable conditions, but in the edge cases, the off nominals, they have to turn it off. And to turn it off in the off nominal, and the off nominals can be 15% of the time, that doesn't go well. So there's a lot. We're still pushing for this, but it's hard. Yeah. Yeah, what I kind of presented here was a little bit of what my team presented at TRB, but they went into way more charts than I showed you. And anyway, go ahead. Okay, when you say canceled, you don't mean cancel on the day. You mean
Cancel the flights, cancel
they're not. Yeah. So yeah, they're no longer providing service. Yeah. Yeah. Yep. Now I get you. Okay. This sounds more DOT, but I don't know what goes in comes out. I mean, I'm still trying to get, are you trying to say maybe more people come to the US and stay and don't fly back? Is that possible? I mean, that's possible, but that would be a DOT thing. Yeah. I'm not sure I'm trying to understand what balanced if there's a market and FAA doesn't get, we are not like Europe. If international, there are more issues because if it's a foreign carrier and a US carrier, we're going to open up routes to foreign carrier, but it's got to go both ways. But that's not an FAA thing. I showed that slide of Asia. It's close. You want to see that slide again? Yeah. That is true, but I do also know though that aircraft size post-COVID did get a little bigger. Yep. For those Asian routes, I don't know. I do not know, and that's kind of a DOT. Because you're right, we focus on the number of because to a controller in the en route airspace, even if it's 5 miles separation, whether it's a 380 or a 737, or a business jet. I didn't show that, but that's something for you to realize that if you look closer, I think I had a slide, but it's the general aviation business jet coming to Florida that is also kicking up the demand. It's not just airline, but it's and general aviation high end kicked up big time during COVID. Why? Because the check-in lines were so long, the inconveniences were long, so business aviation took a jump and it stayed a jump. So if any of y'all are planning to be wealthy, like Dr. Zhang, and be able to fly business jets, no. Go ahead. Yep. It's a great question, and Professor Joe Post works with, but these small aircraft, most of them, in fact, if you looked at the total number of ops in the United States and counted all these little small guys going up for joy rides, it's as much as the commercial aviation. But most of them, if they're flying in clear skies, are not tapping into the air traffic control system. But they're at lower levels. That's the plan. That is the plan, that they're only going to fly during, yeah. I mean, that's where some of us say, why UAM? We have helicopters that could be used, but why don't we do it? Why don't we do the UAM model with helicopters? They're noisy. I don't know that total cost they're more expensive because they're obviously, but in visual conditions, yes. But if you're going to build a business model that somebody's going to count on, and the cloud level is low, and all of a sudden they can't count on it, then but that is the plan. Are we still on on the mic? Okay, but I'll just say in general, some of these aircraft may not be classified as helicopters. And if they're not classified, because to be a helicopter, you got to be able to stop and hover for a while. And some of these, I'm not going to name any, but that may be a challenge for some. Yeah, we're still going through, certifications as to, because, a helicopter can stop, it can hover if it needs to. How long can these things hover with their batteries? And there's questions.
All right, so we have pizza ready, and we'll also have seminar next time, so that will go back. Have different. All right, enjoy the pizza.
Does that include the speaker?
Yes, speaker can get the slides first.
No, I didn't mean that. No. No. So now I know why so many of y'all came here.